Welcome to the Tech Mechanic. Today's breakdown is part of our Azure Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. With that said, let's dive into today's topic. Imagine you are building Instagram, WhatsApp, or an e-commerce application. A customer uploads an image. Now something needs to happen automatically. Maybe we need to resize the image. Maybe we need to scan it for inappropriate content. Maybe we need to generate a thumbnail. Maybe we need to save metadata in a database. But here's the interesting question. Do we really need an entire server running 24 hours a day just to wait for someone to upload a file? No. This is where Azure Functions and Event Grid become extremely powerful. One traditional approach is to keep a server running continuously. The server waits. It checks for new files. Most of the time, nothing happens. We are paying for compute even when there is no work. Now imagine the server doesn't have to wait. The moment something happens, Azure wakes up the function. The function performs its work. And when the work is finished, the compute can scale down. This is the basic idea behind serverless computing. Azure Functions is a serverless compute service that allows us to run code in response to events or triggers without managing the underlying servers ourselves. Serverless doesn't mean there are no servers. Servers absolutely exist. It means Azure manages the infrastructure for us. Every Azure function starts because something triggers it. That trigger could be an HTTP request, a timer, a message, a blob upload, or an event grid event. Remember our previous video about Event Grid? Event Grid answers one question. Something happened. Who needs to know? Azure Functions answers another. What code should execute when it happens? Let's build a real example. A user uploads an image. Blob Storage stores it. Event Grid publishes the event. Azure Function receives the event. The function processes the image. And the final thumbnail is stored back in Azure Storage. Let's use our shopping app. A customer places an order. Instead of making the main application directly call 5 different services, we can use an event-driven architecture. The event is published. Functions can independently perform the required processing. Azure Functions supports many types of triggers. This makes it extremely useful across different architectures. But remember, the trigger determines when the function runs. A trigger tells Azure Functions when to execute. Bindings simplify how the function interacts with other services. This reduces the amount of integration code developers have to write. This is an important architecture decision. Logic Apps is excellent for workflow orchestration and system integration. Functions is excellent when we need custom code. And a mature architecture may use both. With a virtual machine, we are responsible for much more infrastructure. With Azure Functions, Azure handles the underlying infrastructure while we focus primarily on the code. One of the biggest benefits of serverless is automatic scaling. When demand increases, Azure can add compute capacity. When demand decreases, the workload can scale down according to the hosting and scaling configuration. Now let's stop talking about architecture and actually build it. First, check the subscription, and if not, create it. Check resource group, if not, then create it. For this implementation, we took a hybrid architecture approach. To build this event-driven architecture, we started directly in the Azure portal within our resource group, named Azure Resource Group. Create our serverless compute platform, Azure Function App. Because we wanted to leverage a robust, compiled runtime framework, the Azure portal locked down browser editing and instructed us to establish our workspace locally using external developer tools. Followed by we first provisioned our primary data repository, Azure Storage Account 987, To complete the pipeline, we shifted our workflow over to Visual Studio Code. Here, we initialized our code repository, resolved our local package compilation assets, and successfully published our serverless code directly up to the running Azure Function app resource in selected region. With Event Grid bound to this framework, uploading any file payload into Azure Storage Account 987 instantly triggers our deployed handler code, delivering an automated, end-to-end cloud pipeline with zero server overhead. A production architect doesn't stop after making the function work. We also need to know: did it execute? Did it fail? How long did it take? How many times did it run? That's where monitoring becomes important. Now we've moved from a simple demo to an enterprise architecture. Event Grid handles event distribution. Functions perform custom processing. Cosmos DB stores application data. Service Bus handles reliable business messaging. Each service has a specific responsibility. Azure Functions isn't automatically the answer to every problem. For long-running, continuously running, highly specialized workloads, or scenarios requiring extensive infrastructure control, other Azure compute options may be more appropriate. Here's the mental model I want you to remember. Event Grid, something happened. Functions, run custom code. Logic apps, orchestrate a workflow. Service Bus, reliably process business messages. Event Hubs, process massive streams of events. If you remember only one thing from today's video, remember this. Event Grid tells us that something happened. Azure Functions runs our custom code. Logic Apps orchestrates workflows. Service Bus reliably handles business messages. Event Hubs handles massive event streams. Understanding how these services work together is much more valuable than memorizing each service individually. That's how you start thinking like an Azure solution architect. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the Tech Mechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.